Hello everyone, happy Friday. It's the 25th of August. It has literally just stopped raining outside, but it's actually really bright. It was just a heavy shower, but I don't know. That was really peaceful. Less peaceful is the fact that I'm still like kind of stuck on this problem. Um, I think I'm getting somewhere with it though. And that is that it is definitely to do with these square numbers and also the whether x and y is even or odd. Um, because what I noticed is that if if the input y, also I need to put these the other way around. Basically, if y is a even number, then we simply square it to find y to find the value at x0, and then you can uh, subtract as many times as um well, yeah, you can subtract up to y times. Well, you can subtract by 1 up to y times. So this is 13, but this is going to be actually, the next one over here would be 18, 19, 20, 21, 22, as we can see in the example. So I think, to be honest, all we need to do, and that's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah. So I actually think all we need to do is take whichever one is bigger. Um, oh, but they could actually be equal, I assume. If they're equal, then we can just pick y. So let me actually make a note of what I want to do here. Take the larger of y or x. Simply take y if y is equal to x. If y is larger, if y is even, x0, or I guess we'll call it x1, x1 is equal to y squared. And then x at xi, which we'll just say is our input, is y squared minus xi. And I think that's our answer. If y is odd, then we know that x0 is equal, or, x1. I actually need to say, yeah, let me actually get rid of this x notation. So 1y is y squared, or, yeah, 1y is y squared plus 1. So then xy would be y squared plus 1. And we probably want to parenthesize that. Plus x. I think. I also, I want to apologize about last time. I spent a shocking amount of time just staring at the pattern, staring at the spiral, trying to find a pattern. So I think that's one way we can find it. But actually, if x is larger, if x is odd, it's kind of the same thing. So x at 1, y, so kind of along the top here, is equal to x squared. So then x at y is equal to x squared minus x, or minus y. If x is even, then x1 is x squared plus 1. So then xy is x squared plus 1 minus y. Yeah. So I think there's obviously some optimization that can be made here to make it a bit more agnostic as to whether we've picked X or Y. But to be honest, I think we can probably just type this out, to be honest. I'm more just happy that I've actually got some kind of solution. Yeah, so I mean, we can say could just say, you know, we have a boolean that y is greater than or equal to x. So that actually means we want to check for odd. I mean, we check whether something's even or odd by doing floor division. So, is it in CMath or math when we did floor? I think it's in CMath. So, yeah, our modulus number that we want to check is it's going to be 1 if that's true. Or sorry, it's going to be 0 if that's true, otherwise 1 to check if it's odd. So then if let's say x or y rather is okay. Let's see. I want to check that I've actually done that right, because yeah. Let's actually just like check that. So if I was to compile, I'm actually in the wrong folder, aren't I? 2023-25. Ah, okay, that's fine. So a.out, let's say 1, and then if our y is greater than x, which we want it to be, let's say 9.7, that gives us address. But what if I was to just do that? Very different signedness, that's fine. It's still the address, although did I save my I actually save this file, because what I want to do is I want to point to either y or x. So this is, I'm really quite unfamiliar with pointers, we call it. So that's the memory address. I'll put the memory address. I mean, I don't think that's gonna, I don't know. Maybe. Ah, yeah, okay. So we can actually reference it like that. Sure, and it did seem to pick the larger number. I'm also not sure if comparator is the right word here. I think something used as a standard for comparison. What do I call something being compared? Parabol. Yeah, but when you're being compared, I don't know. Maybe I'll just call this like primary. So what we can actually say is if Primary with a modulus over mod, or actually over 2 is equal to mod. So that's checking both of these. And I need to say that. Then how do we output this? We output it per line. Do we have to use POW? POW's in CMath. I mean, maybe floor is as well, but I think maybe I said maybe I said floor before, but I don't think I need to do floor division here. I can just do POW. So if that, then we can just see out basically this formula. So it's actually our primary shit. That's another thing as well, actually. Can we do 10 to the 9? Do double float. Because squaring a number that is 10 to the power of 9 might not be smart. But, I don't know. Could do that. I just don't know how to... I'm just worried about, like, losing precision of this number if I use... I mean, I could just set them to long double. And try, but I think they need to be... Oh, I don't know. I don't know if that's going to work. So +1, but then plus x as well. Which should also be an unsigned long, yeah. Don't know how I feel about this. Although, to be honest though, if I need to square it, I could just multiply it by itself. I could just do primary times primary plus 1. Who needs POW? And just do that. Yeah. Primary times primary That looks really ugly, doesn't it? Plus 1 plus x. Otherwise... Oh wait, we actually need to... we actually need to figure out which one is smaller as well and cleverly use that. That should be pretty easy, actually. That is quite simply if your primary is equal to y, then obviously it's going to be x. Whoops. Then it's going to be x, otherwise it's going to be y. So actually, rather than plus x, it's plus secondary. Otherwise, we do... Actually, it's not... We don't do the plus 1 there. And I need to close out that as well. And I am missing an asterisk. I have a horrible feeling that A, I've really over-engineered this, and B, it's actually not going to work and I'm just going to spend the next, like, 45 minutes debugging. But, whatever. So if we wanted to test this out with something like 22, we would say 1, 2, 3, 4. 1, 2, 3, 4, 5. So 4, 5 should be 22. Yeah. Yeah. Give it a try. Okay, I have 29. Which, I don't know how the hell we're getting 29, but at least it's not some completely weird number. So that's fine. It's, you know, it's kind of there. Actually, if I look at the... It might be just to have gone over one, because that's 26, 27, 28, 29. It's actually just selected it wrong. So it's very close. It's just it's one column over. 26, 27, 28, 29. Yeah, okay. Now why is it doing that? I did say 4, 5. So it is that... So this is the right way round. So in our case, y is less than x. So it's going to use x as the principal or the primary. So that will be false. And so we're actually looking for an odd number for x. So our mod is... Hang on, maybe this is... Maybe it's just that this is the wrong way round? Maybe? That could be it. 1, 4, 5. Oh, that's even worse. Okay, so that wasn't the problem. If primary over 2 is equal to the mod output that we're looking for. Yeah, because if y is our primary, we actually are looking in this case for an even number. Oh, I think it's actually yeah, ooh, wait, I think my notes might be wrong. If x is odd, minus y minus x, then if x is even, xy is x squared plus 1. No, that's plus y. Yeah. It's plus y both times, but okay, that's actually what I've got. And that is plus 1. But I have got minus x up here. Minus. Okay, maybe it's minus. And then we add it. Oh yeah, yeah, of course, yeah, that's reasonable. I don't even know what I'm saying anymore. Right, 1, 4, 5, 21. No. We're closer, but it's still over by 1. Why is it over by 1? I clearly just have a typo somewhere. 25, 24, 23. Yeah, so if it's, you always do want a minus when there, but otherwise you take the square number and you add 1 and then you add the secondary. Yeah, you do. Because for our case 22, we know that it's at 4, 5. So, like 4 down and 5 across. So because 5 is larger, it's going to use x as the primary place to look first. That's going to be the first place where it looks for, or it's going to take x squared. So we know that x is 5, so it's going to go to 25. And we want it to look for an odd number. It might actually be because, yeah, okay. It's because the remainder can be anything. Okay. So this is only true, obviously, if the remainder is 1, which is not what I wanted. And I'm not sure if I can do that with just some ternary statement like this. Yeah. How can we discriminate even or odd then? We check whether something's even or odd dynamically. Because it's either going to be 0 or it's going to be anything greater than 0. but I don't know how to do that dynamically. Um, it might not be. I think I just don't do that. Oh, I've confused myself now. Um, if our primary uh I could I might just copy this twice to be honest. Um so if y is greater than or equal to x, if our primary over 2 is 0, meaning even, so if y is even, then we want to do that, otherwise that. So let me do that. Otherwise, same thing, but we flip the logic around. So this actually just moves over here. Also, is this the machine where? Yeah. And then that goes up there. And I think that should work. Yeah, that looks a bit jank. The whole thing looks a bit jank, I'm not gonna lie. So let's just try this again. So it's now saying mod is unused, which is kind of what we want, right? Was I going for 20? No, I was going for 22. It's still wrong. It's still wrong. Four five should be 22. Is my formula actually right? 22 should be 4 squared plus 5. Ah, actually my formula is wrong. It's that plus 1, plus x plus 1. Which I would have known if I had simply tried plugging it in. But actually, if I do 4, if I was to do 4, 4, 4, that should be 13. So 4, 4, we have an even number, so it should be 4 squared minus, wait, yeah, minus, 4 plus 1. Which, that actually is right, I think, yeah. So that's 16 minus 4, which is 12, add 1, which is 13. Okay. But then down here, is this right if, for example, y is odd? So let's do... Yeah, let's do 5, 2 should be 18. So with the formula we have here, we're saying that 5 squared plus 1 plus 2, that's so wrong, is 18, which is obviously not correct at all. Oh, but actually... No, hang on, if y is odd, we say that actually 5 squared... What am I doing here in the second one? I don't think the second one is right. I think I may have solved the first case that I was looking at, so 1, 4, 5. Oh, I still haven't even... Oh. Probably because I have not saved. Oh, it's still... Oh, right, because I haven't actually done the +1 on these lines. Yeah. But if I was to do... yeah, my 5-2 should be 18. Because what it should be doing is getting to 16 plus 1 and then adding 1. Plus x minus 1. I think. So if I said that y... Yep, so y is larger. And I'm looking at 5-2. I need that to be 18. So 5... I think this needs to be actually y minus 1 squared. And in this case, it's x minus 1 squared. Or rather, no, it's... Oh yeah, no, it is y minus 1 squared plus 1. So we go from 16 to 17 there. And then if our x is... Yeah, okay, I think that's actually right. So that's actually what goes in these equations down here. Yeah. So we actually want to take primary minus 1 multiplied by primary plus 1. Then we add our secondary minus 1. Okay, and let's actually fix these warnings. So this line I don't need. And it's also not happy with this if statement because they're not the same type. Oh, and I closed it. So let's try that one more time. If I do it with 1, 4, 5, we have 22. But if I try it with 1 and what was my other example? 5, 2. That says 22, so that's still wrong. It could be because I haven't corrected this one properly. No. Okay. Those match. Those match. So it's the formula's still wrong, I think. If we were to plug 5, 2 into here, then it would be something like 5 minus 1 squared plus 1 plus x minus 1. And x is 2, which gives us... I mean, we can probably... Whoa, that's not what I wanted. Let me just manually copy that. Yeah. 18. That's what I was looking for. So what have I done differently down here than up there? So it should be the primary, which is x minus 1. Four squared plus 17 plus 2 minus 1. That's our secondary. Might actually be worth just sanity checking. Primary is 5, secondary is 2. Okay, so that's being selected properly. Plus the secondary minus 1. Oh. I think it's because I'm not doing the square properly. It needs to be that. I believe. Hope so, at least. Right. 1, 5, 2, 18. So what if we tried it with their examples? So if we did 3, 2, 3, 1, 1, 4, 2. Okay. Let's give this a try. I'm still really worried that actually this is not going to work at the extreme numbers, because I don't think, 10 to the power of 9, squaring that number, I don't think that's going to go so well, but who knows? Who knows? Oh, amazing. Oh, fantastic. Fan-bloody-tastic. That is great. That is great. I'm sure there is a extremely simple solution to that. But uh, I I don't know what it would be. So my code runs in 0.24 seconds, and someone has got it to run in assembly at 0.01 seconds. I really want to see their submissions. We see their user profile. Maybe they haven't shared how they've done any of these. Yeah. That is unfortunate, but select victim. What? What if I just want to see? Why is that me? Oh, that was what I did just a minute ago. Let's see what someone else has done. So actually a similar principle, mine's just over complicated. Which is surprising. What has this person done? So again, they're looking if it's a... Okay, so my my mathematical principle was pretty much correct. Yeah, that's cool. I want to see the... Is this sorting them? Okay. So some people have it running in 1 second. I want to see the assembly implementation. Well, someone's managed to get it in 0.01 seconds. Can't use mem copy here because buff can be very small. Wow. And then there's the same logic in there, but with a custom scanner and writer that I guess were designed to be faster than STD cout, I guess. That's amazing. That's great. That is great. Cool. Okay. Let's see. 2 nights. We are 50 minutes in. Let's see if we can solve this problem. My task, I'll be right back. I'll be 1 second.